Is it actually possible to have forces in an equation and calculation that is not existing in the free body diagram, which is the basis of the equation and calculation in the first place? That doesn't make sense, right? Bismillah, Assalamualaikum. This video will focus on a specific type of mistake that I observed in the previous quiz, where there's no correlation between the forces in the equation and calculation with the forces in the free body diagram, when in fact it should directly correlate, right? Because when we formulate the equation as well as the calculation, it is based upon the free body diagram. So it doesn't make sense if there's a force in the calculation, but if you look at the free body diagram, the force is not there. Just an example, right? So if we have in chapter 3, where we have equilibrium of a particle. So if we have a particle here, and if we have a force in this direction, right? And of course this force will have x component as such and y component as such in a 2D space, right? So when we do summation of forces in x component or in y component based on this, right? So for example, this is, let's say this is F1, and then we have this theta, right? So you will have F1 cos theta here, F1 sine theta here, right? So when you do summation of fx equal to 0, so you will get the x component that exists in the free body diagram, right? So in this case, F1 cos theta. And if you have another force, for example, let's say F2 here, and then you have alpha, so alpha here, right? So if I draw in a different color, so this will have x component here, which is F2 cos alpha, and it will have y component there, which is F2 sine alpha, for example, right? So and because for fx it will be in the negative direction, if we take positive to the right for this example, it will be minus F2 cos alpha. And if this is the only forces that exist there, equal to 0. Obviously this is not equilibrium, but just an example, right? So when I look at the equation and when I look at the free body diagram, it should correlate, right? Of course this is not free body diagram, this is an illustration. The free body diagram will be, in this case you'll have F1 here with theta and F2 here with alpha, right? That's the free body diagram that have, is it in the diagram? Okay, I hope this is not outside of the frame, right? So if you look at this and you look like this, all the information is there, right? So F1 is this one, theta is this angle, F2 is this one, alpha is this angle. So it correlates, and that is what should be. Now what I observe is sometimes students write, draw and write like this. Let's say they have something like cables like that, right? So if this is point A, this is point B, this is point C, right? So and then you have something there, for example, right? So when you draw the free body diagram, what should happen is you should draw the body, which this is the particle, and then the forces that is acting on this body, right? So this cable will exert the force to this body in this direction. This cable will force on this body in this direction. This weight will have a force downwards like that. That's the drawing. And then we label the force, right? So for example, I can use it FAB, and then I can use FAC, right? FAC, then I can use W, for example, right? Let's say. So if this is what I do, and let's say we have theta here and alpha here, right? So when you draw, when you do summation of forces, For example, summation of fx equal to 0, taking to the positive as to the right as positive. So I should have, for example, f a b cos theta minus f a c cos alpha equal to 0, for example, right? Now, when I look, okay, this FAB, the force AB, FAB is this one, okay? Theta is this one, FAC is this one, alpha is this one. So it correlates. Now, I notice some maybe there's a misunderstanding of what they should put here, because some actually put something like this, BC, something like that. And suddenly here, FAB, FAC, right? So, wait a minute, what's going on here? Are you saying this force is C and it is not here, and this force is B is not here, and FAB is nowhere to be seen, FAC is nowhere to be seen, right? So what's going on? If you're saying this is a point, then that creates another issue. When you go back to the concept of free body diagram, free body diagram should be free from the surrounding, right? So when we take free body diagram of this particle, of this point, of this ring or whatever, it should only have that ring and any forces that act on that ring, right? So this cable is replaced by a force, this cable is replaced by a force. So if you're saying this is the point, so are you saying this is not free from this one? Hence, then you do not have a free body diagram. If you say this is the force, how come the label is like this? Because this is already used as the point, right? And it doesn't correlate as well. So there's something that you should really understand when you do free body diagram, right? So the label is the label of the force, meaning we give the label or the name of the force. Okay, if I use F1, then it should be, for example, if this I label as F1, this F2, so here should be the same, F1 and F2, for example, right? And so on. Of course, in this case, it is more difficult to follow if suddenly you label 1 and 2, and I have to trace back which one is 1, which one is 2, right? So it's logical to have FAB, FAC, right? So make sure you understand when you draw the free body diagram what you are drawing, right? And what you are labeling here. And interestingly, someone actually have both, right? They have FAB, and then B is also there, FAC, and C is also there, right? So this is more confusing to me, right? Okay, which one is the force? Which one is the label of the force? And the other one is what exactly, right? So be sure to revise back. I know when we cover the theory of free body diagram, because it's just the theory, we just want to solve the problem. You know, as a student, we do not care that much, right? But the understanding of what exactly is being drawn is fundamental to why we draw it in a certain way, right? What else? I think that's the thing that I just want to highlight here, because for some of you, alhamdulillah, you are okay, but for some of you, the equation, and meaning the force in here, is not existent in here, so that's a problem, right? I think that's all for this video. It's just a straightforward, actually. I hope after this no one will make this kind of mistake ever again. Hopefully it is understood, and see you next time.